There we go, live. Okay, so this is problem number 8 in section 4.7 of your homework. Let's set it up. So we got a Norman window. Norman window is a regular rectangular type window with a semicircle on the top. So it looks kind of like that, semicircle. So let's see, Norman window, blah, 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 blah. What is the area of the largest possible Norman window with a perimeter of 20 feet? So we know the perimeter is equal to 20 feet. Let's see, so semicircle at top, the rectangle, so that the diameter of the semicircle is equal to the width of the rectangle. All right, so we have a length here, or a height, let's call that height for H. And we have a width here. And then as far as the width, that's the radius. Ooh, that's not a radius. That's a radius. Okay. So what I'm going to do is I think I'm going to go for, what do they want? They want, what is the area? So I'm going to use, I think, R. Yeah. Yeah. So W will equal 2R. So I think I'm going to do it that way.
I tried it the other way and I messed myself up. And then
with the half. Yeah, I think this will make it easier. Yeah, if we do that. So as far as perimeter goes, we have this semicircle at the top, right? So that's going to be half of 2 pi r, which is pi r. And then we have a height coming down that way and a height coming down that way. So we have 2 heights. And then the width is 2 radiuses. So we have 2r at the bottom. So that right there should be the distance around, right? We have semicircle, we have a height, we have another height, and we have 2r across the bottom. Okay, so there's my perimeter formula. Next, area formula. Switch colors. So area, in this case, is going to be H times 2r for the rectangle, plus half of pi r squared for the top. Problem here is I have too many variables, so I'm going to have to use this to whittle down my area formula, because we are trying to find the largest area based on a fixed perimeter.
Is that a 2 below?
Or is that,
that should be a 2.
okay.
Weird. What happened there? Don't know. My brain and hand did not communicate properly. Yeah, okay, so there's the 2. So right here, I think the easiest thing to do would be to solve for H. So then I'm going to take the 2H on one side, and on the other side, I'm going to have 20 minus pi r minus 2r.
I think we got a sign error.
I got a sign error somewhere. So the 2H stays where it is. I subtract over the pi r, and I subtract over the 2r. I think I'm okay. And then I cut that in half, and that's going to give me 10 minus pi over 2r minus r.
Oh, you moved everything else. Okay, never mind.
Yeah, sorry, I just kind of flip sides and then move stuff. So this is my value for H, and I need to put it there for a new area formula. So my area then is going to be, I think I'll write the 2r first, times this stuff, parentheses, plus pi r squared over 2. And it probably benefits us to clean this up a touch. So distributing, and then looking for like terms. What do we get? New color, let's come over here. We get 20r. We get, see, the 2 and the half cancel there. So that's going to give me a pi r squared. So minus pi r squared. And then minus 2r squared. And then we have that plus pi r squared over 2. Okay, like terms here, well, there's a whole bunch of them. I guess I'll put these two together. So if we take pi r squared and we took away half of pi r squared, that leaves us half of pi r squared, but the negative rules there. So oops, this is equal to 20r minus pi r squared over 2 minus 2r squared. And we could factor the r squared out of that if we wanted to. Do we want to?
We have to.
No. Just leave it? Okay, we'll just leave it. So now we've got down to a variable, a function of a single variable, r, and we're ready to differentiate with respect to r. And you guys can do that. Setup's the hard part. Okay. So I mentioned before, I cannot do these without drawing a picture and then putting stuff together or eliminating variables. The things that helped me out here the most was I'm trying to find what the largest area is. So that means I've got to have an area equation that is down to a single variable. Okay, so I was thinking about that, and then I figured I had to use the perimeter to make that happen. Okay, so the procedure of these is pretty much the same thing. Draw yourself a picture, write down every equation you can think of related to the problem, pick the one that is going to be involved in the derivative, and then use the other equations to help whittle down the variables. Differentiate, set it equal to 0, and solve. All right, so you guys can finish that, hopefully. Next.
Number 9.
Number 9. Find the point on the line 2x plus 7y plus 6 equals 0, which is closest to the point 3, 0. So I'm going to ask Desmos to draw this for me, even though I could probably do it myself. So 2, 7, 6. Okay. So 2x plus 7y plus 6 equals 0. Did I type that right? 2x plus 7y plus 6 equals 0. Yes, I did. And then I want the point 3, 0, which is right there. Okay, so let me screenshot that to draw on. Let's get that much of it and blow it up. Okay, so find the point on the line that is closest. I think you can do this without calculus.
Then what's the point of having it in the calculus class?
I don't know.
You just have to find
I
the
think it's like
perpendicular.
optimization or something.
So there's two ways to do this. So first we're going to do it with calculus, and then I'll show you without. So if I pick any point on the line, like this point right here, that point has some x value, right? And it has some y value. And if I solve this for y right here, I'm going to subtract the 2x to one side, I'm going to subtract the 6 to one side, and then I'm going to divide by 7. True?
Mm-hmm.
So that's what y is equal to. So a point on this line is a point that has the form x comma negative 2x minus 6 over 7.
Mm-hmm.
And then the distance between any 2 points is governed by the Pythagorean Theorem,
Where?
right?
Mm-hmm.
This distance right here.
Oh, yeah.
If I know this vertical part here, and I know this horizontal part right there, then I can find that distance. So according to the Pythagorean Theorem, that distance right there is equal to the square of the distance between the y values. Well, this y value is 0, and this y value is right up there, right? So that means I want this minus 0, say. So that's going to give me negative 2x minus 6 over 7 squared, plus the distance between my x values. Well, this x value right here is 3, right? And that x value right there is x. So 3 minus x, or x minus 3, it doesn't matter because you're squaring it. So I would choose to write it as x minus 3 because that's a little easier to deal with. And there's 2 choices from here. You could either square the distance and then use implicit differentiation, or you could say d equals the square root of this side and use the chain rule.
Is the 3 from your?
The given point here,
Okay.
that's the point 3, 0. Yeah, it's the x value from the point. Yeah, so this is using the fact that Pythagorean theorem finds the distance between 2 points, okay? And then one of the points is governed by the equation above, and I can just solve for y to get x and x in terms of x for that point. Yeah. So then you would just take the derivative of this nasty thing. Okay. But I think this might be doable without, hold on your sheet. Okay. And then if you want to just do a quick comparison yourself.
Okay.
Don't change anything though.
No, I will.
I'm sure you aced it though. Okay, so the other way I think we could do this would be to just think about geometrically what it's going to look like to be closest. So let me copy this to a new screen just for fun. Feel pretty good?
Yeah.
All right. Congratulations. It's good there. Have a great day. Okay, so check this out. So would you agree that if the point is over here, it would be shorter if the point was there? If the point was over here, it would be shorter if the point was over there. So where do you think the closest point on this line is going to be? Perpendicular, yes. Okay. Do we know the slope of this line?
We can figure it out.
We do. We actually have it over here. It's -2/7. Okay. So the slope of this line right here is -2/7. The perpendicular line is going to be the negative reciprocal. So this one right here, m perp, is going to be 7/2. Okay. So can we find the point on this line? Yeah, all we need is this equation right here, and then just solve for x and y, solve a system of equations, bam, we got that point. So it turns out this one is solvable without calculus if we make the observation that the closest point will happen if we have a perpendicular direction to go on.
Wait, so if it shows up on the test, can we use either one?
If I don't specifically say use calculus to optimize this, yes, you could use either one.
Wait, so
If it just says find the point on this line closest to that point right there, you don't need calculus in this case.
once you have the slope, you just use the point slope formula.
Then I would just use the point slope formula.
Okay.
Yeah, so this line right here would be y minus 0 equals 7/2 times x minus 3. And we know the equation to this line right here. We know two different versions of it. Use any method you want to find the intersection of those two lines. And bang, you got it. Yeah. Fun math. Woo! Okay. Did anyone try any of the problems from Newton's method?
No.
Okay, then I'm going to do another Newton's method problem, and then I'm going to jump into antiderivatives, which is, you know, like, it's exciting. It's almost as fun as antimatter. Anti-calculus, antiderivatives. All right, so let's see. What do the last few problems more interesting?
Let's do the graph one.
Okay, let's do the graph one. All right, so let me zoom out a bit so I can see that sucker. Oh, I guess I need to zoom out more. I think that'll be okay. All right, so let's see. Can I capture that? No, it's probably an SVG. So I have to capture it this way. Have you guys ever heard of SVG images? It stands for Scalable Vector Graphic. And it's images that are made up entirely of mathematical functions.
Oh dear.
It's wicked cool stuff. And many things on the web are shifting from JPEGs and PNGs to scalable vector graphics whenever possible. Because usually they take up less disk space and they scale beautifully and always look nice. Okay, it's pretty exciting. You can see I'm excited about it. All right, so let's shrink that down just a touch. Okay, so Newton's method, and then shall we use Desmos or a spreadsheet? Desmos? Okay, Desmos it is. Even though a spreadsheet's way more efficient, that's okay.
But then I have to use a spreadsheet.
When you're applying for a job in the future, if you can put on your job application, master of spreadsheets, that will definitely get your foot on the door. I'm telling you, the phrase master of spreadsheet on your resume will get you places.
But literally everybody says that. I know how to use master of spreadsheet.
There's a difference saying I used Excel in the past to saying I'm a master of spreadsheets.
Until they
How do
make
you
you
know
take
that? I
a
don't know if any of
test.
us have that.
A spreadsheet says.
We can
Yeah,
sit down and talk and then
Certificate.
I have badges for master of spreadsheets. I can get you a badge.
A badge?
Yes, and they even have
Seriously.
sashes to go with the badge.
Okay,
Mine
so
over there right now.
Okay, all right, let's focus. Sorry, that was a tangent. Let's get back on track.
a tangent line.
And
Okay.
if you don't do it just the right way,
So
Microsoft prescribed way, you're wrong.
we want to find that intersection point. But what does Newton's method apply to?
Zero over
Limits.
zero.
No, that's L'Hopital.
Oh.
L'Hopital is limits if it's 0 over 0, infinity over infinity. So sometimes you have to massage the equation to get it into something L'Hopital likes. Newton's method is for finding roots.
When you have like.
That is not a root right there. However, well,
That's
root just
square root.
means where it hits the axis. Yeah, so Newton's method would find this point or that point, but not that point. However, I can edit this equation to make it look like I'm finding a root.
Edit the equation.
Yes, I will edit the equation by just subtracting this sucker on the right over to the left. So I'm going to rewrite this equation as the cosine of x squared over 7 minus x over 4.5 equals 0. So now this right here is my function f of x, and I am now finding its root, or one of its roots. Okay, this is number 8. Yep. Okay, so that's the only trick here. Once I've got that down, then I take the derivative. So f prime of x is going to equal, let's see, derivative of the cosine is the negative sign. Chain rule says leave the x squared over 7 alone for a moment, but then multiply by it. So that would be 2/7 x, or 2x over 7 if you prefer. So that's the derivative of that part. Negative 1 over 45 is just a constant. Derivative of x is 1, so then I'm going to have a minus 1/45, 1 over 4.5. Okay, so then to set up Newton's method, we always start with some x value and then we subtract the ratio of the function to its derivative. So the function is the cosine of x squared over 7 minus x over 4.5, and then we divide by its derivative, negative sine of x squared over 7 times 2x over 7 minus x over 4.5. And then that's the function I plug into either my spreadsheet or my Desmos.
1 over 4.5.
1 over 4.5. Oh my gosh. Yes, thank you. Whoa. Good job, Sarah. Okay, 1 over 4.5. And so the request was to plug this into Desmos. So I'm going to scoot this out of the way for a moment so I can see it on one screen and Desmos on the other. And let's get rid of that. So what do I need here? I just need to enter that function. So x, oh, and I need to give it a name. Let's call it n of x for good old Newton. And then this is equal to x minus fraction cosine of x squared over 7 close parentheses minus x over 4.5. So there's my numerator. And then the bottom, opposite of the sine, there we go. That was tough. Of that again, x squared. Whoa, that's a crazy sucker there. Over 7, close parentheses, multiply by 2x over 7 and then subtract 1 over 4.5.
That's cool.
Wow, that's a wicked cool function, eh? All right, so then we use this in a recursive manner. What were we told to start at? Were we given a starting point? Usually we are. Here we are not. Okay, but we can look at the picture and guess 2.5 maybe?
Sure.
So I want n of 2.5. That gives me 2.59. I'm going to give that a name. LM, how about m equals? So then I go, okay, what is n of m? 2.5, and I'm looking, they wanted 5 decimal places, so I'm looking to where these match for 5 decimal places. I'm going to give that a name. How about O? Then I want n of O. Do they match yet? 5, 8, 9, 2, 2. Yeah, I got enough decimal places. So it only took me 3 tries. So mine is 2.58922. Tyler, what's up?
Is there a benefit of overestimating or underestimating for the first one, or is it the same?
Like if I kept going?
Well,
No,
well,
for your
what-
first
for your
number
first
that you
guess.
choose.
Oh, overestimate or underestimate? Oh, so what if I called that like 2.6 instead or 3? No, there usually isn't. If you stray too far, depending on the function, that can throw you outside and then and weird shit could happen. But I should be okay if I plug in, like if I plugged in 23, that would probably mess stuff up. But if I plug in 3, I just need to do one more step of Newton's method to get there. Yeah. So the further away you are, one of 2 things will happen. You need more steps in Newton's method to get where you want to be, or it could throw you out of bounds and weird stuff happens.
Wait, how'd you choose your number again?
I just looked at the graph and I said, you know, that looks like about x is 2.5. You know, I could have picked 2.7, might have been a better pick. It might have gotten me there one step sooner, but maybe not. So there you go. Not too bad.
Great, can I see
Right.
the graph one more time? Sorry. Okay.
Yeah, so here, what do they want? They just want the root. They don't want the y value. They just want the x value, which is that the x value that leads to that intersection point. That's all they asked
Stuff
for.
that you get from.
Yeah, so mine would be from Desmos 2.58922. Might as well get a 2.58922. Get a thumbs up from the computer. Woo, I got it right.
can they see the work that you did to set it up?
Yes. So the work, oops, sorry, that's over here. The work generally looks like this. You have to make sure you have a 0 on one side if it wasn't already there. Once you get that, that gives you your function. Then take the derivative. Then the setup from there for Newton's method, it's always x minus the function divided by its derivative. That's what Newton's method says to do. And then you just repeat this. You pick an x value to start with, you get an answer. That's your next x value, and you just plug it back in. So that's called an iteration or a recursion.
So we just couldn't use the original one because we had x's on both sides.
Yeah, the original one had x's on both sides. So the question is, okay, well, what's f of x in that case?
Okay.
Yeah, so Newton's method works only for finding where a function hits an axis, which means you have to set your function equal to 0. So you have 0 on one side, whatever's on the other side, that has to be your function.
Wait, so
Can you, what was the answer that you got? Sorry, I was doing it in a spreadsheet.
Yeah, so I got, Desmos told me it was 2.58922-ish. And although I have had a spreadsheet on my smartphone before, I find spreadsheets on a smartphone are very painful.
I have it on
To
Google
use.
spreadsheets on the app to do it. But
Yeah, the Google app on Google Sheets app on the phone is kind of tricky. Yeah. Okay, new topic.
Antiderivatives.
Antiderivatives.
You sound so excited.
Because they're exciting.
They are
You
excited.
know.
Antiderivatives. I find almost all of math exciting. There's a couple of areas of math that I find very difficult and try not to tread there sometimes. Well, one is mathematical logic. I find painful.
Okay. Okay.
The other is number theory, which is the theory of prime numbers.
That equally sounds painful.
Which, well, that one I don't find it intuitive at all. I find it very, very difficult. It never came naturally to me, but I love playing with it, even though it's painful. Whereas logic, I don't really like so much playing with that.
Okay, Gary.
Yeah, so there's some areas of math that I really struggle with, but I like to play with. There's other areas I struggle with and I just don't like. I haven't found an area of the calculus side of math I don't like yet. Okay, so antiderivatives. So it's the opposite of taking a derivative. Okay, so what's like the opposite of multiplication?
Division.
Yeah, so it's kind of like that. So for example, with division, if I had something like 6 divided by 3 equals what? I could rewrite that as math and say, hey, what times 3 is 6? Oh yeah, it's 2. Right? And we do a lot of division that way. We think, oh, what would I multiply by? Right? How does long division work? You guess, what's a multiply by? You do it, you subtract, you repeat. Okay, so antiderivatives are kind of the same idea. What's up?
So wait, with antiderivatives,
Yeah.
are we making the function that we're working with the slope function and then our answer?
Yes! So Sam hit the nail on the head.
Oh.
So what we're going to do is we're going to say, I took the derivative of some function, f of x, and for an answer, I got 3x squared. What could the function have been? Whose derivative is that?
1. So
X.
it'd be
Siler?
x to the cube.
X cubed.
It's x cubed. So if f of x equals x cubed, maybe plus 5,
Plus.
then the derivative of that is going to be this right here. So the catch with antiderivatives, if there was a constant added on to that function, when you take the derivative, it goes away. So with antiderivatives, what we usually do is we say, this looks a lot like x cubed's derivative to me, but there could have been some constant hanging on. So we usually throw a plus c on there and say, there could have been a constant.
Oh, what's the point?
This is antiderivatives.
What's the point?
I will get to the point of this next quarter. So this is a, you know, like, did you ever watch a series on like Netflix or whatever ever? And what do they do right at the end of the last few minutes? Something suspenseful happens to make you watch the next episode. So this is the suspenseful
So I'm
section
just gonna be sitting
to bring
here
you
the whole
back
night.
Gonna be on the final.
to Calc 2. No.
So you're teaching us this to make us take the next term because now we want to know why the hell we have to learn this.
You know what? I think I'm going to put a question like this on the final. So suppose f prime of x, is equal to 2x. What could f of x equal?
X squared.
It could equal x squared, or it could equal
X squared plus c.
x squared plus 1, or x squared minus pi, or x squared plus any old constant you want.
X squared
X squared plus or minus some constant.
Yeah, so usually we could just say plus c, and c could be positive or negative.
Okay.
Okay. All right, let's do another one. I took the derivative with respect to x of some function t of x, and I got the negative sine of x. What function am I? I am, that's my alarm that I need to shut up in a minute. So that means t of x must be the cosine of x. All right, one more, then I'll shut up for the day. Sorry that I go too fast there. Yeah, so this is the idea of an antiderivative. Here's the derivative. What could the function have been? Oh, right, plus c. I forgot the plus c for a constant. Yeah. And on the homework, when it asks for an arbitrary constant, I think it accepts capital or lowercase c. But just keep that in mind. What's up?
Is it possible to take a second antiderivative?
You can.
Why are you asking
Yes.
questions?
Yeah, so it is possible to say the second derivative with respect to x
Put it back.
of some function was equal to, let's call it x. Okay, so we would go back a step and say, okay, could we name f prime of x? Well, let's see. the derivative of a square is an x, but there's a catch, right? If I said this was x squared, what's the derivative of x squared?
2x.
2, I'm missing the
So it's
2.
1/2.
So then, yeah, take 1/2 of that to adjust. Okay, but there could be a plus c there. We don't know. There could have been, right? All right.
Yes.
Well, this is some derivative. Okay. Now let's say, okay, could we guess at what f of x was? Well, if this is a square, then the original function must have had a cube. The 1/2 is just chilling, but this is missing a 3. So we also need a multiple of 1/3. And then constant came from the derivative of a linear function, right?
Could it?
So there must have been a cx here,
Yeah.
but there's got to be another constant. So let's go k for constant that time. Yeah, so, and this just can go on forever. This leads to another awesome idea in calculus called differential equations,
Salad, I hate you.
which is a whole nother course in math that you would do after Calc 2, which most of you are likely to have to take in the future.
Is it?
It's math, usually it's called math 256.
Yay.
Yeah, so not only do most of you get to take math 252 and 253, but some of you have to take 256 and 254.
Wait, I just have a question.
Okay, hang on, one question at a time. First, Ruby.
Okay, so it says general antiderivative. Is there a difference between the regular?
A general antiderivative means put the plus c on there.
Okay.
Yeah.
That's all I was.
Silent.
Did you figure out which course you're taking during the spring?
Most people voted for 253.
Yes.
There's a slim chance we'll offer 254, but the problem then is we're competing against ourselves. And the people that listed both 253 and 254, there were 4 people that said they wanted to take both of them. Only one of them said they might take both at the same time. Which
Was that an option?
I at one quarter I did take 4 math courses in one quarter, and it was rough. It was rough. 3 in one quarter I found was my limit.
I literally am already having problems. with one
So
class.
What your soul would take.
yeah, so